Strength of material, SOM. In strength of material, we study the internal force distribution and deformation developed in actual engineering structure. But here we will study about the different type of forces like tensile type of forces, compressive forces and shear forces. Before starting, I would like to explain to you that each and everything available in the real world are in 3D form, but here we will convert 3D-dimensional object into the 2-dimensional object like this. This is the 3-dimensional object cross-sectional area, maybe the T-section, I-section, circular cross-section, square cross-section. So different kind of cross-sections area we have. So like this is the cylinder. So in 2-dimensional form, in 2D we convert like this. This is the 2-dimensional. This is the axis of this member. Here we will represent the axis of the member is like this. So this is the cross-sectional area in 2-dimensional form. The cross-sectional area is, this is the line. This line is the cross-sectional area of this cylindrical object. Suppose here we have another square cross-sectional area object like this. So in 2 dimensions, this is the cross-sectional area of the object. In 2D, it represents like this. So this is the axis of the member. Okay. So now here I will proceed with a different kind of forces. Like one is your different type of forces or types of forces. One is your tensile force, second is your compressive force, and third one is your shear force. The force nature is here tensile type, means it try to elongate the member. The force nature in second is compressive, it will try to compress the member. This is the shear force, means it try to shear off the sections. And this is the tensile types. Tensile types means here we will try to elongate this members. Like this is the object, so this is the the force will try to extend this member. Here I will represent like this. This is the tensile force. Suppose this is 3-dimensional. There is no load. 2D representation is like this. When we applied the load, okay, 2D in 3D and 2D, no load. Okay, and we applied the load. Suppose in no load condition is like this. This is the initial length of the member and diameter is di. When we apply the load, the cross-sectional area of the member it reduces and it is acting along the axis of this member. So this is the normal. Normals means acting perpendicular to the cross sections, and uniaxial means in 1 dimension along the axis of this member. So this is called the normal uniaxial tensile force P. Okay, so here the final length is your LF and diameter is your DF. So longitudinal strain is your change in length over initial length. So LF minus Li over Li. So this comes, LF is greater than Li. Here this is positive. It comes, longitudinal strain comes positive. But suppose I want to calculate the lateral strain. So lateral strain is your change in dia over initial dia. So final dia minus di over di. So lateral strain it comes negative. So when longitudinal strain comes positive and lateral strain comes negative, the sign of longitudinal and lateral strains gives you the information about the forces or nature of the force. So when longitudinal strain comes positive and lateral strain comes negative, means applied load is your tensile type in nature. Now compressive force. In compressive force, the force will try to compress the member. Suppose this is the member, no loading case. When you applied the load, so no loading case, when you applied the load, so the cross-sectional area of the member it increases. Okay, it increases the applied load. This is acting perpendicular to this cross section and about the perpendicular to this cross section along the axis of the member. 2D representations is like this. You may represent like this. The load is perpendicular to these cross sections and acting along the axis of this member. So in this case, suppose final diameter is df and final length is your L suffix f. Initial length is your Li and initial diameter is your di. So longitudinal strain is your change in length over Li, means Lf minus Li over Li. So it comes negative. Why? Because Lf is less than Li. Lf is less than Li. The lateral strain change in dia over initial dia, df minus di over di. It comes positive. So here in this case, when lateral strain, longitudinal strain comes negative, lateral strain comes positive, means applied load is your tensile type in compression type in nature. Okay. Now third one is the shear force. Shear force which try to shear off the sections. Means in this case the load act parallel to the cross section. Like friction force is our shear force. The shear force is the force which act parallel to the cross section. This is my cross section. So it will, suppose it is fixed at the base, so it will try to tilt this member. So it will tilt like this. Suppose this is my A, B, C and D. So A dash. So this is my phi. So tan phi is your shear strain A dash over AB. Okay. So the one is your tensile type of force, another one is your compressive force, shear force. So the tensile force is the force which try to elongate the member, compressive force which try to compress the member, shear force which try to shear off the section. In tensile type, it will extend to the member, compression type it will compress to the member, shear force it try to shear off the sections. Thank you.